Welcome, this is 7.4. How can you solve a quadratic equation by graphing? X squared equals 4. We might graph that. We can graph the x squared. You know it looks like this. And then on top of that, we can graph the 4. We know that it looks like this. And we've just intersected those two functions at positive 2 and negative 2. Are those solutions to the equation? Negative 2 squared, negative 2 times negative 2 is 4. Positive 2 times positive 2 is 4. So that's an easy way to graph a quadratic equation and get the answer. We just simply split it off. We graph it as f of x equals this side of the equation, and g of x equals this side of the equation. It's a straight line. Okay, now my question for you is, this was two solutions, real nice, everything's cool, but how could you either move this line or move this line, transformation I'm talking, translation actually, in order to only have one solution? You might have said, well, let's keep the, wow, that was not straight, I apologize. Let's keep the 4 there, and let's simply move this up 4. I know that that's a plus 4 on my k. So I'd go x squared plus 4. Now if you think about it, it's only got one solution, it's at 0. That's my solution. If you went to solve that, minus 4 on each side, x squared equals 0, x would end up equaling 0, so you've done a good job there. Now, what about if I had no solutions? Well, since these are where the parabola and the straight line intersect, that means for no solutions, they can't intersect. I want you to come to class and bring this up and explain what your answer is. So now let's solve this one graphically. First thing I want to do is I want to graph this, f of x equals 2x minus 4 squared plus 1. So I go to my vertex 4, 1. So I go 1, 2, 3, 4, up 1. Remember, if it's a negative, it's actually to the right because that's a positive 4 in there. The negative's in the formula. Okay, now I'm going to stretch by 2. So over 1, up 2. Over 1, up 2. And then I need to go over 2 and up 8. Over 2, up 8. There is my parabola. And now to graph my g of x equals 7, I'll just come up to 7. I'm so sorry. And draw a straight line. Definitely use a ruler in class. Okay? So this shows the two solutions. They are at approximately, boy, it's not going to be quite out 2 yet, because up here at 8 it's out 2, so 4 minus 2 is 2, so it's going to be like approximately 2.2. And on the other side, it's not going to go out quite 2, so 4, that would be 6, so not quite at 6, so like 5.8. You can put those on a graphing calculator, put this in your y1 and that in your y2, take your trace button and find where they actually intersect. That would be a good thing to test yourself. Make sure that you've estimated those well. Okay, so we've got a tightrope walker at the circus. He's 20 feet up on the high wire, and he falls. The net catches him. The net's 5 feet up, and we're wanting to know how much time elapses because this was a retired tightrope walker, and if it's more than just a second, if it's more than a second, his heart might stop. So let's figure this out for him. Okay, and we just want to figure it out real quickly in the audience before we know, hey, is this guy good or not? So, what does the 5 foot, why did they include that in the problem? Remember, this is your height. Well, when he hits, his height is 5 feet. So that's why we have that. So we have 5 equals negative 16t squared plus 20. They want us to solve this graphically. So we know the k value is 20, so we would go up here. Now we're in a stretch of negative 16. So at 1, we're going to be at 16. Now by reason, you might have just said he's alive. Because our net being 5 feet up, 5 from 20 is 15. So our net is right here catching him. Okay, and that's, he dropped 16 feet in 1 second, but it isn't quite 1 second yet when he hits the net. All right? You could go ahead and algebraically solve it, but I just like you to use reason on these problems. Thank you very much.